Welcome to Biostudy Pathshala. I am Nilanjana Sharkar with you and wishing you a very safe and healthy day and hoping for your best. I hope that you are maintaining a proper regulations and taking care of you and your family as well. So let's get back to today's topic. So today's topic is biochemistry, and it would be the part 2 of the biochemistry. And in our today's class we will learn about the physical properties of water, the concept of pH and concept of the buffer solutions. So let's see how much we have already learned and how much we can learn today. So let's see. So what is water? We know water is a universal solvent because of its polar nature, and maximum of the substances almost present on the earth can dissolve in water, and those substances which can dissolve in water are polar substances, and they show a affinity to dissolve. That's why they are called as hydrophilic substances. And some substances cannot dissolve within water, rather they aggregate within water, and they are called as hydrophobic substances. They have not an affinity, rather they have a tendency to avoid the water because of their non-polar nature. Water shows a movement from its higher concentration to its lower concentration, and this procedure is known as osmosis, and it occurs in the presence of semi-permeable membrane. If we can assume that it is a semi-permeable membrane and it is a container, and this side shows a lower water molecule and higher solute and lower water, and this portion shows a higher water molecule while lower solute molecule. So here, and it is a semi-permeable membrane, so the water will move from this direction to this direction. So this procedure is known as the osmosis, while the solutes show this kind of movement is known as diffusion. But here no semi-permeable membrane is needed, and it also occurs from the solutes higher concentration to the solutes lower concentration. That means if we assume that it is a container holding water and we are putting a drop of eosine, it will take a certain time to dissolve from its center to the whole container. So it is the diffusion procedure. So next is the pH. We all are aware of the two terms, the base and the acid. So how we can determine whether a substance is basic or acidic? So here is a way that we can determine whether a substance is basic or acidic. It is called as the pH. pH shows whether a substance is acidic or basic. So it is the measurement procedure of a substance, or a measurement procedure of a acidicity or basicity of any solutions or substance. That means the degree of the nature, and it is expressed as the negative logarithmic of the total hydrogen plus ions present on that solution. The pH ranges from 0 to 14, and pure water shows pH about 7. That means neither acidic nor basic. Acidic solution or acid shows lower than 7, and the basic shows higher than 7. As you can see in this figure as well, that 7 shows a neutral value, and the purple color shows the basic solutions or the basic substances, while the orange shows the acidic solution. That means here the detergent shows highest pH, after that bleach, after that ammonia solution, after that baking soda, after that seawater. Human blood shows almost 7.4, which is slightly basic, and milk, urine, saliva almost ranges from 6.3 to 6.6, which is slightly acidic. Black coffee again acidic in nature, as because pH is 5. Grapefruit juice, soda, tomato juice also acidic, as because it ranges from 2.5 to 3.5. Lemon juice is 2, and the battery acid highest acidicity because it shows pH less than 1. So the low pH indicates a acidic property and more hydrogen plus ions concentration, while the high pH will indicate basic solutions and less hydrogen ions concentration. We will see the relationship between pH and the H plus concentration in our next slides. So let's see. So as I have mentioned that the pure water shows the pH of 7, as you can see in this pH scale as well, that the 7 is for neutral, it is for basic, and it is for acidic. And the pure water shows the ionic product of hydrogen and hydroxyl ion, and this value is 10 to the power minus 14. That means ionic product means the multiplication value of the total concentration of the hydrogen ion and hydroxyl ion is 10 to the power minus 14, and the pH value of pure water is 7. At first, see this equation, that is the pH is negative logarithm of the total hydrogen plus ion concentration. That means if pure water shows pH is about 7, that means we can write down that in this way, that pH equals to 7 and minus log H plus. So we can write down in next step that log H plus equals to minus 7, and if we omit the log, it would be in this way, that the concentration of the H plus would be 10 to the power minus 7. And if a pure water shows 10 to the power minus 7 hydrogen ion concentration, that means we can write down in this way, that hydrogen ion is 10 to the power minus 7. OH, we don't know about OH, and total ionic product equal to 10 to the power minus 14. So OH minus ion concentration would be 10 to the power minus 14 divided by 10 to the power minus 7, and next step would be 10 to the power minus 14 plus 7 equals to 10 to the power minus 7. So the OH concentration again would be 10 to the power minus 7. That means the pure water shows the concentration of both the ions are equal, and as you can see that pH and the hydrogen shows a inversely proportionate relationship. So we all know that acid shows a lower pH, and lower pH means negative log H plus ion. So negative means a inversely proportionate relationship. So If the pH is low, that means acid, and it has hydrogen ion concentration is more, while if pH is high, mainly for base, shows less hydrogen ion concentration. It is also applicable for OH minus ion, and the POH is the negative logarithm of the hydroxyl ion, and POH is again inversely related with the hydroxyl ion. It would be minus. So as you can see that acid shows lower than 7 pH and base shows higher than 7. And if a solution contains more hydrogen ions, that means it will contain less hydroxyl ion, as because if a acidic solution, that means it will contain more hydrogen ions, but it will not contain that much hydroxyl ion. If hydroxyl ion concentration is high, then the solution will be in basic nature. And if we know either H plus ions concentration or OH minus ions concentration, we will determine the pH or the POH and another ion concentration. The pH and the POH are always dependent upon temperature. That means the fluctuation of the temperatures can affect the POH as well as the pH, but the additive value, that means the cumulative value of the pH and POH, which is 14, cannot be affected by the temperature, as because this additive value is not dependent upon temperature. So as you can see, the ionic product of the pure water shows H plus OH minus is about 10 to the power minus 14. So how we can prove this? We already know, okay? Just remember, pH equals to minus log H plus and POH equals to minus log OH minus. Okay, so if we start from this equation, we will operate log 10 on both sides. So H plus into OH minus, and it would be log 10 to the power minus 14. On next step, we can write it in this way, that log H plus log OH minus equals to minus 14. We all know about log property, I think, that if log operate on xy, it would give log x plus log y, and if x to the power y, we operate log upon this, we will get y log x. That means the power will come before the log. So the power is minus 14 will come in front of the log, and log 10 base 10 will give 1. So on the next step, we can write down that in this way, that log H plus log OH minus equals to minus 14, as because this value is 1. On the next step, we will multiply minus on both the side. So we can write this, that minus log H plus minus log OH minus equals to 14, as because minus multiply and give result to plus value. And we know that minus log H plus equals to pH, while the minus log OH equals to POH. So we can write down this, and this would be the pH plus POH equals to 14, and it is proven. So I think you can understand. So next is the importance of pH in any biological organism. So why we should study about pH? We are from life science background, and what is the necessary for studying the pH? As because we are organisms and we are made up of cells, and cells are again made up of carbohydrate, lipid, proteins, and what we take as a food, the foods are digested by the enzymes. Enzymes are again protein in nature. So protein shows always a efficient function in an optimum pH. So enzyme will also show an optimum pH to function efficiently, and it might also be affected by an inappropriate pH. And the specific pH is needed to retain a structural and the functional integrity of maximum biological organisms, maximum biological structures, as because maximum biological structures are made up of protein, and our system like antibodies, hormones are again proteinaceous in nature, so they can also be affected if the pH fluctuations occur. And pH also can regulate the speed, rate, and the nature of the chemical reactions in any biological system, and the enhancing effect or the decreasing effect of the biological or the biochemical reactions may affect the living properties of the organisms as well, because these reactions are very much important for the living of any organisms. As for example, if we consider about the pepsin and trypsin, we all know about these two enzymes. Pepsins and trypsins we can find out on our digestive tract. Pepsins on stomach, while the trypsins from intestinal tract. So pepsin show a optimum pH at 1.5 to 1.6, that is a acidic pH, while the trypsin shows a basic pH which ranges from 7.8 to 8.7. And the human blood cell also show a optimum pH which is 7.4. If pH fluctuates, these enzymes will not work in a proper basis, and human blood cell can also disrupt its function. So next is the buffer solution. What is the buffer solution? It is a mixture of weak base and its salt with a strong acid, or the mixture of weak acid and its salt with a strong base. If we consider two examples, we will consider two examples. One is for weak base and strong acid, and one for the weak acid and strong base. So weak base, as we know that ammonium hydroxide is a weak base, and its salt, which is NH4Cl, that is ammonium chloride, is made up from ammonium hydroxide and the hydrogen chloride. The mixture of these two substances is acting as buffer solution, and again weak acid, that is acetic acid CH3COOH, and its salt, that is CH3COONA, that is sodium acetate. The mixture of these two solutions again act as the buffer solution. This solution is known as the basic buffer, while this solution is known as the acidic buffer. And if these buffer solutions are very much essential to balance the pH within a solution. If a small amount of strong acid and base is added, the pH of that solution remains almost unaltered, as because they can resist the imbalance in the pH. For example, if we add more hydrogen ion, that means if we assume about this example that the CH3COOH will give to CH3 COO minus plus H plus, while the CH3 COO Na will give CH3 COO minus plus Na plus. If we add more OH minus in this solution, they will combine to form water molecules. And if we add more acidic solution, that means more hydrogen plus ions, that means they can combine with acetate ion to form again acetic acid. So ultimate, the total pH of this buffer solution and also the given solution will remain almost unaltered. So the acidic buffer, that is the mixture of the weak acid as well as its salt with its conjugate strong base. That is the mixture of the CH3COOH and the CH3COON, that means acetic acid and the sodium acetate. Here the acetic acid is weak acid and sodium acetate is a salt of this acid which is highly ionizable. And as you can see that acetic acid can dissociate in this two form, that is acetate and the hydrogen ion, while the sodium acetate can dissociate in the acetate ion and the sodium ion. Sorry, it would be minus and it would be plus, as well as it would be plus, hydrogen would be plus and it would be minus. Just you can correct please. And if we add more OH minus, that means if we add more base in this solution, this OH minus will combine with this H plus and will produce H2O. And the formation of H2O cannot change the pH of any solution. And if we add more acid, that means more H plus ions, this H plus ion will combine with this ion and form acetic acid. That means the total volume of the acetic acid will increase if we add H plus ion, and if we add more hydroxyl ion, then the total volume of the acetic acid will be decreased. So as you can see in this slide as well, that the acetic acid with water can dissociate in this way, that hydrogen or hydronium ion and the acetate ion. And if we add more base, then the total amount of the acetic acid will be decreased while the acetate ion will be increased. And if we add more acid, the total amount of the acetate ion will be decreased and the total amount of the acetic acid will be increased. So this is the buffer solutions functions. So next is the basic buffer. It is the mixture of the weak base and its salt with its conjugate strong acid. And it is the mixture of, as I have mentioned before, that ammonium chloride and ammonium hydroxide. Ammonium hydroxide is a weak base while the ammonium chloride is a salt which is again highly ionizable. And ammonium hydroxide will dissociate like this way while the ammonium chloride will dissociate in this way. If we add more acid in this solution, that means high hydrogen ion concentration, this excessive hydrogen ion will combine with the hydroxyl ion and form H2O. That means no pH change. And if we add more OH, that means base, it would give that NH4OH, that means the ammonium hydroxide. So if we add more base, the amount of this NH4OH will increase, while the adding of hydrogen ions, that means adding of acid, will resulting the decreasing of NH4Cl. So this is just a summarization that if a solution have a original buffer pH, if we add basic solution, it would give almost approximate unaltered pH to the original solution. So next is the Henderson-Hasselbalch equation. It was firstly discovered by Joseph Henderson, and he has given only this equation, and it was based on the carbonic acid buffer solution, that means a buffer solution equation. And after him, Carl Albert Hasselbalch re-expressed this as a logarithmic form of this equation. So if we this equation as logarithmic, what we can find out? Let's see. Before, we should know that Ha is a acidic solution, a buffer acidic solution, which can dissociate and form H plus and A minus. A minus means anionic, and K plus is the equational constant, the equilibrium equational constant, which is the ratio of the product or the multiplication value of the product divided by the reactants. And if we operate log on both the side, we can get that log, obviously base 10, Ka equals to log H plus A minus by Ha. It would be the concentrations of these substances. Next, log 10 Ka equals to, we can write down in this way, that log 10 H plus log A minus by Ha. And if we multiply minus on both the side, we can get that minus log Ka equal to minus log 10 H plus minus log 10 A minus by Ha. I hope you can understand. And we know that minus log H plus equals to pH, and the minus log on Ka would be the pKa, and it would be, we can write this in this way, that log 10 as same as it was. So if we arrange this equation, we can write down that pH would be pKa plus log 10 A minus Ha. So A minus is the salt and Ha is the acid. So we can write down in this way that pH equal to pKa log 10 salt by acid. So this is the Henderson-Hasselbalch equation. So it is the slide representing this equation in a understandable way. So as you can see that K equals to H plus into A minus divided by total Ha, and if we operate log on both the side, we can get this equation, and if we multiply the minus, we can get this is pKa, and this would be pH, and this is the acid by salt. So I hope you will understand the Henderson-Hasselbalch equation. So I hope this session is helpful for you, and if it is helpful, just give a like and share this video as much as possible with your friends, family, seniors, juniors, and so on. And also don't forget to subscribe this channel, and also you can follow this channel on Telegram as well as on the Facebook page. And don't forget to press the bell icon to get notification so early. So thank you, and wishing you very safe and healthy day ahead. Thank you.